Hi everyone, we are going to talk about scatter plots. And scatter plots, you can see the pictures and says there's a whole bunch of different ones. And the R is a number we can actually get from the calculator that's called correlation. And correlation tells you how close is all the points, how close they are to the line you can draw. So if the points are exactly right on the line, and the correlation will be 1 or -1. Points is everywhere, and you cannot draw a line to narrow down where all the points are located. I'm sorry, wrong one. It's going to be like this. The ones in the middle says no correlation. That means the points are scattered anywhere and you cannot put a line to it. And that means the correlation is 0. So the correlation is falls between 1 and -1. And if the 0 means no correlation. And then if the line goes from bottom up, the correlation is going to be 1. And if the correlation goes from top down, it's going to be the negative. So it's going to be between 1 and -1. And depends on the slope of the line, it's going to tell you that's going to be positive correlation or negative correlation. And when correlation is at 1, is the points is exactly on the line, and the -1 is also the same thing, exactly on the line. So you can decide where your correlation, and then we're going to describe highly positive correlation or highly negative correlation, depends on the situation. Okay, so in this case, let's read through it. And one quick thing is, do not forget all the red words. You need to write it down in your notes, and make sure you copy down all the information. Okay, so in this case, let's start. In the first unit, we mainly focus on data that had been collected for a single variable. Such data are called univariate data. From the first data are either qualitative or quantitative, and that all quantitative data are either discrete and continuous. So you should remember discrete is just 1, 2, 3. Continuous is 1.1, 1.2, 1.3, and anything in between. Next, in this chapter, we will be collecting information about 2 different variables on each object. Such data are called bivariate data. Each variable can either be qualitative or quantitative. So we can look at studies with 2 qualitative variables, 2 quantitative variables, or 1 each. That means 1 qualitative or 1 quantitative. In this unit, we are going to focus on bivariate data for 2 quantitative variables. That means 2 numbers variable. Another quick review, X stands for explanatory variables and also stand for independent variables. And what that means is we are investigating whether the X might be explained, affected the Y. Okay. 2. Y response variable is dependent variable, and also we are investigating whether Y will be response to or be affected by the X. So Y will be affected by X. Example number 1. Consider the following data table. Year since 2000. So if it's 2000, it's 0, 2001 is 1, 2002 is 2, and so forth. So in 2000, the price of a certain item is $2. And then 2001 is 7, 2002 is 12, 2003 is 17, and 2004 is 22. So in this case, what pattern do you see in this collected data? Well, I would notice that the pattern is if you look at the X value, you will say this is going up by 1, and this is going up by 1, and going up by 1. And this one is going up by 5, this one is going up by 5, and this is going up by 5. So because of that, you can say every year the dollar amount goes up by 5. That's A. What patterns do you see in this collected data? Every year, the price goes up by $5. Example 1B says, use the pattern that you see to predict the price in 2013. Well, since we know the pattern by now, I'm going to just add a couple more to the list and then write down the numbers. So 2013, based on years since 2000, is actually 13, and I'm going to try to figure out what is the number in year 2013. What does that match up to? So you guys notice the pattern. I use a purple line to separate and add more years. And then if I go up by years and up to 2013, that's $67. So I hope you guys understand that. So those two matches up right here, 13 and 67. So that is going to be my number for letter B. Use the pattern that you see to predict the price in 2013. So write it down. In year 2013, the price is $67. Example 1, letter C. Use the pattern that you see to determine when the price will be 52. So we already made the chart, so let's go back and look at 52. I'm going to use the green. So $52 will be right here. That is right here. And then it's going to be coming back to the other one, match up with the 10. So in this case, don't forget that 10 representing from 2000 and then 10 more years after 2000. So in this case, in year 2010, the dollar amount will be at 52. Plot the points for letter D. If you plot each row of data as the order pair, what type of graph do you get? I'm going to plot them, and then we can take a look at it. For letter D, if you plot each row of data as order pairs, what type of graph do you get? Well, it's going to be a line, and that's going to be a word that we use from chapter 1. It's called linear. A line is a linear graph. Okay, and then the order pair they are talking about is going to be 0 and 2, 1 and 7, 2 and 12, 3 and 17. And that's your order pairs. And I give you lots and lots of order pairs all the way from 13 and 67. You don't have to graph all of them because you should be able to see the pattern. Okay, so that's example number 1. Now example number 2. Example number 2 is almost the same thing. So let's see. It says, consider the following data table with a price column rewritten. So this is what we have before. Okay, and then we now going to write an expression. And expression, if you remember from chapter 1, is everything with an x and a number, but there's no equal sign. That's the expression. So in this case, to write expression, and then if you remember expression, you're going to substitute the ones with a letter with the number that keep on changing. And in this case, it will be the year since 2000. So since they give you an X, and that's what we're going to write down. So you should be able to see the numbers that keep on changing is going to be the 0, the 1, 2, 3, 4. And those are the number, because it's changing, I'm going to replace it with the X. And that's the best way to think about it when you write a expression, because that is going to be represented by a variable. So now let's take a look at the question they want us to answer. Okay, letter A, write an expression. We've done that. Next one, how are the pattern that you notice in example number 1 represented in this expression? Well, the really important thing is that we say where the points we started. We started at year 0, 2000. We started at 2, because you can see 5 plus 5 times 0, that's 0. So it's going to be 5 plus 0, 2 plus 0. And because that is the case, we are going to say that the price is increasing by 5, but starting at 2. So I'm going to write that down for you. Okay, so B, how are the patterns that you notice in example 1 represent in this expression? Price will go up by $5 every year, with the starting price at 2 at year 2000. And the next one is how are the number in this expression above represent in the graph? Well, the $2 is going to be the number when is year 2000, and you can see that based on the graph you see above, which is right here. In year 2000 it's going to be $2. And then as it goes up, it says $5 is the price. Sorry, that should be that. Goes up every year after year 2000. Okay, and that's example number 2. Let's do example. You should be able to tell me the pattern do you see in this collect the data is after every minute the bacteria is double. So we're gonna say number of bacteria is double after every minutes elapsed. Okay, so that's A. 2. B. Use the patterns that you see to predict the number of bacteria after 10 minutes. So in this case, I'm going to pause it. You guys go ahead, write out the chart, just like what I did. If you need to have a little bit more space, you can use it on the other side of the column. But I'm going to just list 0 through 10 and then see what we got, okay? Okay, so I label out my table. I have all those numbers. Again, 0 is 3 bacteria, 1 minute is 6 bacteria, 2 minutes 12 bacteria, and if you go down to 5 it's 96 bacteria, and 6 is 192 bacteria, and if you go to 9 it's 1536 bacteria. And as the question letter B asks, use the pattern what you see to predict the number of bacteria after 10 minutes. And in this case, after 10 minutes, I have the matching of 10 bacteria is 3,072 bacteria. So I'm going to pause that and write that down for you guys and try to answer the question letter C and see can you get the same answer. I will put the answer down for you. Letter D, I have using the pattern that you see to predict the number of bacteria after 10 minutes. And we already talked about it by setting up the patterns. I have 10 minutes at 3,072 bacteria. And then in C, use the pattern you see to determine when there will be 768 bacteria. And I done the same thing because we did it before. So we can just pretty much pick up the numbers, and that will be 768 right here. And therefore that matches up with 8 years. And that's 8 minutes. Okay. And then the next one, letter D, plotting the points, which is I did. And don't forget your label, your x-axis and y-axis. X-axis is the x, independent variable, and then the y is going to be the dependent variable, and that's going to be the response variable. Curvy line, not a straight line. And because the curve is not a straight line, it's going to be non-linear graph. Non-linear means it's not a straight line. So I will be using those two words, vice versa sometimes. Talk about interpret scatter diagrams, which is we kind of did before, but in a more organized fashion. Before we have a line, which is if we can draw the dots on the lines, the correlation is equal to 1, which is r equals 1. And now we're going to have points everywhere, and then we're going to discuss how are we going to, write the equations maybe. If we don't cover it now, we will definitely cover it a little bit later. And then we're going to talk about correlations, and probably that's going to come later, and this is just in pieces. So first of all, we're going to learn how to do scatter plots and draw and interpret scatter diagrams. So when given bivariate quantitative data to study, a relationship exists between the two quantitative variables. For example, let's say that we want to try to predict a person's final exam grades for the course. What might be some variables that affect a person's final exam grade? Now jot it down, think about it and come back and check with mine. Yours might not be the same as mine, and it's okay. Those are some of the examples I have that might, some of the variables that might affect the person's final exam grade. How much time you studied, study time, how much did you sleep, how many questions, how much materials covered. So all those can be what might be some of the variable. Well, those are all kind of variable, and there's some other variables that you might have. Okay, so in that case, that's not a big deal. You guys all can think about different things. That's totally okay. We believe that the variables we have listed above should have some predictable effect on a person's final exam grade, probably most likely study time. That is to say that we think we would be better able to predict a final exam grade of a person in class if we know the value of the variable listed above, because we think there is an association. That's a very important word. We're going to talk about it in a minute between them. Okay, so here we go. Association. Association exists between variables when one of them is related to the other in some ways. Okay, so how much time you study, probably what's the better grade you're going to get. So one, we can use the word association when we're talking about either qualitative or quantitative variables. Two, the numerical association is referred as correlation, R. So in this case, recall from what we talked about before. If your R is 1, it's very close related, 100% related. If you don't have any correlation, that means your number is close to 0 or 0. That's no correlation. Okay, as the number gets smaller, the correlation is less. If the number gets closer to 1 or -1, the correlation is bigger. All right, so going back to look at it right here. So first step when organizing data is to make an appropriate graph when you have bivariate data. The first graph we make is a scatter diagram, or we call it a scatter plot. So in the scatter diagram, a graph that shows the relationship between two quantitative variables measured on the same individual object. Each object in the data set is represented by a point in the scatter diagram. So X is the variable being used to explain the explanatory variable or independent variable, and that's on the x-axis. Y, the variable that responds, the response variable, dependent variable, or that's on the y-axis. So think about the bacteria problem that we did before. The bottom, which is the x-axis, the minutes elapsed, that's on the x-axis, and that's the independent variable. Number of bacteria is the dependent variable. That's the number of bacteria, and that's also the response, and that's the y. And then so in that case, we are going to next one. That we use the explanatory variable to help predict the value of response variable. That means we're going to use the x, predict what's y. And then for example, our study can be used to estimate the test score. You should know a few things about the graphs so far in this course. One, we are going to use technology to make them, either TI-84 or Desmo. Two, we are usually looking for something in particular after we made the graph. For example, we are looking for the first bar, and we are looking for the correlation or write the equation. 3. Real world data never looks as perfect as the picture in the math book. So we're going to use data from different kind of situation. And after the graph that we are going to be done with them, which is I'm going to show you an example for in a minute, you need to be able to answer 4 different questions. 1, what's the form look like? And this is very important. This is in the AP test and everything else too. So the form is the shape of the graph. Is it linear, which is a straight line? Is it quadratic? Is a curvy line? Exponential just keep on going up. Quadratic is, let's draw it down so you guys know what I'm talking about. A linear is going to be looking like a line. A quadratic is going to be something like a tulip shape. Okay, and we're going to talk about that. An exponential is going to be something like the bacterial growth that we just did, and just curving and go up very, very fast. Okay, it should be above it. And something like that. So keep those graphs in mind. And also, there's also another one, scattered everywhere. We are just going to say nonlinear or not something I can predict. Okay, and the direction, positive goes from left to right. This is positive. And negative goes down from left to right. And it's going to be this way. And then neither, when the graph is neither positive or negative. And eventually I will show you some other things, but right now we are only touching those 3 things. And then as you get harder in your statistic graphs, maybe some other topics will come up and they will talk about different kind of shape of the graphs. Now strength is how tightly the points are clustered around the path of graph. So strong clusters, everybody very close to that line, the correlation is going to be 1 or -1. If no association, they don't cluster anyway, they just flow everywhere, that's closer to 0. And then go back and take a look at the very beginning graphs and the pictures, you should know, or the figure. Weak R value is not close to 0 or 1, like a 0.6 or 0.4, things like that. That's weak. Okay, because it's closer to 0 or 0.3. Unusual feature, looking for the points that does not seem fit the pattern of the rest of the data. Those could be the outliers, which is something that's totally strange, somewhere floating outside of a normal graph. So definitely take a look at that because they will ask you identify what is an outlier. Example number 4. The weight and highway miles per gallon were recorded for 10 randomly selected cars to see if the weight have any effect on the fuel efficiency. The results are as follows. Please pause your video and do letter A, and we will come back. Then you can turn back on and check your answers. Example number 4. The weight and highway miles per gallon were recorded for 10 randomly selected cars to see if the weight have any effect on the fuel efficiency. The results are as follows. Please pause your video and do letter A, and we will come back. Then you can turn back on and check your answers. So my answer for letter A is individual object is the weight and the highway miles per gallon for one car. And the explanatory, which is X, is going to be the weight. And the response variable is going to be the highway mile per gallon, how many miles it will go. And next thing what we're going to do is use your calculator or decimal to make a scatter diagram for the data. Label axis and vary with label axis with variables. So that means you need to tell me what's x-axis, what's y-axis. So what we're going to do is we are going to learn how to enter the data and make a scatter plot onto the TI-84. Okay, so here we go. You go to stats, and then you are going to enter the data, which is 1, edit, and you are going to go up to L1 and press clear and press enter, and that will clear up. And you're gonna do that same thing for 2, clear, press enter, and then you will clear everything. Let me try again, and let's go to stat. Okay, so now what you're going to do is you are going to enter the x value in L1, which is right here. So I'm gonna put 2948 into L1. So 2948, press enter, and 3536, press enter, and 34. And I'm gonna pause it right here, and you guys can do that. And when you're done with that, put highway mile per gallon onto your list too. When you start entering, it should look like this. If you scroll up and down, you should see I enter all my numbers, and that's 1 is 23, 2948, and 3536 is match up with 19. 2472 is match up to 19. And double check your numbers and making sure that everything is correct, because you guys know me, I do make mistake. So double check, it never hurts to do that. And then that way will save you some headaches later on. 2649, and then 25, 26, 2665, and 3374, and 21, 25, 23, 21, 16, 14. Okay, so now what we have is we're gonna quit out of it, okay? And then we're gonna graph this thing on and give me get a scatter plot. Okay, now one thing you have to do is, I don't remember, you guys remember that we need to change different kind of graph we're gonna get. So we're gonna go to second stat plot. Okay, now second stat plot, you guys remember we used to do a box plot right here. We did a histogram right here. So what you're going to do is you're gonna make sure it's turned on, and then we are going to press enter. And then here are 6 different types of graph you can pick. You can pick, make sure you understand that's on right there. And then we go down to pick what type we want. And first one is scatter plot. Second one is a line graph histogram. And then next one we have a box plot with outlier, just regular box plot, and different kind of graph with more other things that you have to worry about later on. And then we have list 1 for the X, that's very important, that's L1. List Y, which is, this is your dependent variable, that's your this is your independent variable, this is your dependent variable. X is this way, and Y is this way, okay? So list 1 is going to be this. List 2 is going to be the mileage, okay? So after I do that, I'm going to press zoom. And then because I'm on scatter plot, I'm going to be zooming statistics or stats. Press enter, and there is your graph. Now don't forget, the weight of the car is on the bottom, and the highway mileage is going to be on the Y. And then you're going to copy this down and put it in the position right here. And I'm going to do that on the video for you. So pause it, and then you guys can see that. Okay, and then we're going to answer the questions, and then we'll be done. I hope you guys understand how to put a scatter plot into your graph now. And I will show you how to do it that small when we are in class. Then the next thing is, this is the graph I expect to see. Don't forget, you put your weight of the car, which is pounds, on the x-axis, and the highway miles per gallon on your y-axis. And now that's the answer to the questions. The question says, C, describe the association between the weight and the fuel efficiency in those four things. Now, if you try to remember, the four things are, if it's a form, first form is going to be the shape of the graph. And the shape of the graph says you have choices of linear, quadratic, exponential. So in this case, it's kind of a line lining down. So therefore, it's going to be linear. And next one is going to be the direction. Well, the direction is positive, negative, or neither. So take a look at this. I would say there's a trend of going downwards like this, kind of. Okay, so therefore, we are going to put down, going from down from left to right. So that is going to be a negative direction. Then the next question is says the strength. Well, the strength, if you think about it, is how close to the line. Well, if I talking about how close to the line, if I draw a line right there, it's kind of close. So I would just say somewhat close. Okay, if it's not totally clustered right around it, so it's kind of close correlation. Or you can say strength is, there might be a point that does not quite fit the pattern. Maybe this one right here. Eventually, we definitely will talk about that when we put the line in and see how far does it go away from the line. So we will talk about it. But in this case, unusual feature, I would say maybe that point out there. And that's probably going to be the one that is further out on the mileage, which is, or the weight of the car, which is a 4,000. If you want to think about it, because further out is the weight of the car, and that's probably going to be the 4,000 one right here, and then 16, and that will probably be my outline unusual feature. Don't forget, unusual feature is for the for looking for the pattern. It does not fit the pattern, or it could be the outlier. So maybe one outlier at 43.67 is the weight of the car, and you can only go 16 miles per gallon. Okay, so now that's the notes for scatter plot. Please let me know if you have any questions.